Alright, today we're going to be covering congruency. Now, congruency or congruent shapes refers to shapes that have the same exact properties, so they have the same lengths and the same angle. So we're generally referring to 2D shapes. And generally, when you hear the word congruency, you generally think of triangles, which is what we're going to be covering today. But it doesn't only cover triangles, it covers all other 2D shapes as well. Now, there are 4 types of congruent triangles we're going to take a look at today. The first type is referred to as side-side-side or SSS. So if you know that 3 corresponding sides, so all the sides in a triangle, are the same as the sides in the other triangle, but it's just been rotated, you can then assume that those 2 triangles are identical. So for this diagram here, where I've put one line, it corresponds to the one line on the other triangle. That's how you can tell which sides are equivalent. The second type of congruency, so triangles that are identical, is SAS. We have 2 sides and then an angle in between them, or an angle to the side. The important thing here is the 2 sides and where the angle is on the first triangle needs to be in the same order on the second triangle, even if it's been rotated. So you're going to have this angle now in the top right or top left corner. It needs to be in the same position between the 2 lines here, like it was in the original one. Now the third type of congruency is sometimes referred to 2 things as either angle side angle or angle angle side, depending on which side they're thinking of. So you have 2 corresponding angles and then another side that's the same on both triangles. One's going to have to label them there for you. So it could be another side, let's say here or here, but as long as it's the same side corresponding on the other triangle, once you've rotated it, then you can have this sort of congruency. The last type is when we're dealing with right angle triangles. If you have 2 right angle triangles and they have the hypotenuse, so let's just label it x. If both of the hypotenuses are the exact same length, we have a right angle and then we have a common side, either this one or this one, then we can assume those triangles are equivalent and we can assume they're congruent. So you need to have a right angle, an equal length hypotenuse, and another equal length side. Now one set of letters we're not considering is AAA, which is angle, angle, angle. The reason why that's not congruent is even though the angles are the same, the sides could be scaled up and the angles could still remain the same in another triangle. So then those 2 triangles wouldn't be identical. So that's just one you have to avoid. So let's take a look at a couple questions where we can use each of these examples. The first one. So we've got a parallelogram here. It says prove that triangle ABC is congruent to triangle BCD. So in order to make that triangle, let's first split the parallelogram correctly into 2. So one's ABC, so we're probably going to split it this way. So there are our 2 triangles. So since we're not given any angles, it's probably either going to be SSS or RHS. Now since the parallelogram doesn't have any right angles, we're probably going to need to have SSS. So we need to find 3 sides that are the same. Now you know in both of them you have the side BC. So BC is the common side in both of them. So we have our first S. So we'll just underline that. Next, you know that opposite sides in a parallelogram are equal. So we'll put lines on it. So therefore, AC is equal to BD, and you just want to state the reason. As opposite sides in a parallelogram so we have another side, and then using this same rule, you don't have to state again, AB is also equal to CD. So we'll just draw an arrow showing we're using the same rule. So here's side, And then you just want to conclude. So you need the concluding statement. So say side, side, side. So therefore, that's what the three dots means. Triangles ABC and BCD are congruent. And that's it. So you found the three sides, and you just make sure you conclude at the end. Alright, let's look at another example. So this time we're given a triangle with two sides and an angle. So you probably know it's going to be two sides and an angle, so SAS. But compared to the previous question, if you take a look at it, we're not given any vertices, so we might want to add them on ourselves just to make things easier. So you always want to make sure you add your own vertices. So we stick with simple ones, A, B, C, and then D, E, F. Now, you want to make sure the angle here is between the two sides, and we know the angle here is between the two sides. So we can use SS. The reason I want to say that, if the angle was over here, then we wouldn't be able to use the rule. So let's take a look at AB is 6 centimeters, which is also equal to 6 centimeters on the second triangle, which is EF. So we have a side. Now BC is equal to 8 centimeters, which we also have as DE. So we have a second side. And now we have angle ABC. So to make sure it's an angle, you just want to put a hat on the middle letter, is equal to angle DEF, which is 65 degrees. So we have an A. So we have AS. So therefore the triangles are congruent. So you always want to make sure you conclude at the end. Next. So here you can tell we have a right angle, so we probably want to use RHS. Now the only problem sometimes you might find is we're given two different lengths. So this should be a 12. So on one triangle we have a base of 5 and a height of 12. On the other triangle we have a base of 5, a hypotenuse of 13. So what you want to do here is you'll need to find the third side and make sure they're both the same. So ideally this should be 13 and this should be 12. Now the way to do that is to use Pythagoras' theorem, since we have a right angle triangle. So remember, a squared plus b squared is equal to c squared, which is the longest side. So here 12 squared plus 5 squared is c squared. Now 12 squared plus 5 squared gives you 169. So c must be 13, which makes sense since this is 13. So we can assume this is 13 and this is 12. So you need to show this step. And then we can say both sides have a right angle. So both triangles have a right angle. Once again, we will make sure we label the corners so we can refer to them later. A, B, C, D, E, F. Alternatively, you can also write ABC equals 90 degrees, which is equals DEF. Next, to use RHS, remember the H means the hypotenuse needs to be the same side. So you can say AC is equal to DF, which is equal to 13 centimeters. So we have an equal length hypotenuse, and then any other side, BC is equal to DE, which is equal to 5 centimeters. So we have our third side. So we have RHS, so therefore the triangles are congruent. Next, so here we're given two angles and a side. The only problem is here, we're given different angle for the second angle in both triangles. So what you have to spot is sometimes you will need to find a third angle to make sure the two triangles are congruent. So we know all the triangles should add up to 180. So the third angle should be 180 minus 30 minus 50, which is 100 degrees. And that makes sense since this angle is 100 degrees. So we label that as 100 and we label this as 50. So we know we have at least two angles on the side, so it's going to be ASA this time. And once again, we want to label them A, B, C, and D, E, F. So we have a common side, so AC is equal to DF, which is equal to 5 centimeters. Then we have an angle of, so let's use the one we were given. So angle BAC of 30 is equal to angle EDF of 30 degrees. And let's use the angle 50. So ACB is equal to DFE 50 degrees. So we have angle, side, angle. Therefore, the triangles are congruent. So you just want to make sure, once again, with this one, that the angles you've picked are corresponding with the side. So you can't pick the 5 if it was, let's say, on FE instead. Alright, now what I want to go over is a non-example. What I mean by that is, sometimes they'll ask you to find if two triangles are congruent, but sometimes they might not be congruent, and they might just be testing you can check it. The reason why this is a good example, it looks like they're congruent because they're giving you two sides and an angle. So ideally we should have SAS, but what you notice is, if we were to rotate it, the 40 degrees is next to the 3, but opposite the 4. But if we rotated it, the way we have it this triangle, that 3 would technically be here and not here. So technically the 3 would be on the other side, so therefore this side wouldn't be 3, it would be another length. And then this angle 40 would actually be this angle up here. So in this cases, the triangles are not congruent. So you just want to make sure you double check that the lengths and angles you're finding are corresponding correctly. You don't always want to assume they're going to be congruent. And last, we'll do another exam question just to finish off. So we've got an irregular quadrilateral here. It says prove that angle ABC is equal to angle ADC. We're given that AB is equal to AD, so let's put two lines there. And then BC, double line, is equal to CD. We need to prove that angle ABC, let's label that X, is equal to angle ADC, let's label that Y. Now there's a couple ways to do it. We can split this shape into triangles. So if we split it down the middle, we have two triangles here. Now if we want to prove the angles are the same, if we prove that the triangles are congruent, then those angles have to be the same since they're the corresponding angles. So we have that AB is equal to AD, which is given to us, so there's a common side, and BC is equal to CD. That's also another common side. Now if you notice this AC, which is split down the middle, since that is the common side, So as in, what I mean by that, it's the same in both of them. We have another side. So if you have side, 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 the triangles are congruent. Now remember, what does congruency mean? Congruency means that any 2D shapes will have the exact same lengths and angles. So if the triangles are congruent, angle ABC must be equal to angle ADC. So that's all we're doing there.